Search in rotated sorted array. In this question, we are given an array which is sorted in ascending order, but the twist is that this array has been rotated by some number and the index of rotation is also unknown. The problem, and we just have to search for a target element. So sorted array, finding a target, instantly the algorithm that comes to mind is binary search. But to apply binary search, we need the array in ascending order. So we basically need the sorted array, but then that array should not be rotated. Okay, so what can we do? The main idea is that we can just sort this array once and then apply binary search on it. So that would be, sorting would be around n log n, and then finding L element would be log n. So that's a O of n log n algorithm. But then if we do that, then what's the point of like having a sorted array which is just rotated? So can we further optimize it? We can actually. How? So we are given this array which is sorted. So if you see that, so probably the original array was this, and then this original array was rotated by some amount. So 1 2 3 4, so it was rotated by 4. So it is rotated by 4 in right direction. So on rotation, what would you do? We get 0 1 2 here, and then remaining element would come forward. So 4 5 6 7. Okay, now if we somehow see, this is a point of rotation. If we somehow see in this array, if we see that we can divide this array into two parts. This part is one sorted array, this part is one sorted array. So if we somehow can find this point in the array, probably in time complexity which is less than or equals to O of n, then if somehow we could find this point, then we would just apply binary search on this part and then this part, and then we would get our answer. So in fact, finding this point in O of n is quite trivial. How? So you would see this all this point here, 4 is greater than 5, 5 is greater than 6, 6 is greater than 7, but on the pivot point the element to the left would be smaller than 7. So here 7 is greater than 0. So on the pivotal point, what would happen? That array of I would be greater than array of I minus 1. Sorry, array of I plus 1. So if you get it, let's say this is the I, then what would be our sorted array? So what would be our point where we would divide the array? That would be from 0 to I, and then I plus 1 to n minus 1, and then we just apply binary search and just divide it. But can we do better than this? Okay. So the only way to do better than this is to apply binary search on it, because it is a sorted array. It is just rotated. So if we can apply binary search to find the pivot point, then our work would be done. So how can we do that? Let's see. What you would notice is that in this example, let's say 4 5 6 7 0 1 2. Let's say this is our low and this is our high. Now When we apply binary search, what would we do? We'll find the mid, that is low plus high by 2. So that is 0 plus 6 by 2, and that is 3. So 0, 1, 2, 3. So our mid will be this. Now, can you see what's happening here? The mid pointer is greater than L, or let's say 0 index is greater than the 0 index. So array of mid is greater than array of 0. Since this is greater than 0 and we know that this array is sorted, so that means in between all the elements should be sorted. So that means this is one sorted array. So our pivot do not lie here. So where would our pivot lie? It would lie on the right side of mid. So we would move our left pointer to here. Okay, then our mid would be this. Now what you see that, see if you compare this mid to low pointer, then you would again get this is one sorted array, but you have to find the pivot. So what will be the property of pivot? See, every element which is left of pivot. So this is our let me do this once. Let me erase this. So every element, let's say this is a1, a2, a3, and this is our pivot. Let me denote it by ap, and then let's say this is ap plus 1, and this is ap plus, let's say n or n, whatever it is, some index. Now every array is sorted. Sorting means this part is something like this: a1 greater than a2 greater than a3 up to p1. At p1, this is happening. This is less than ap, and every element to the pivot is greater than this: ap plus 1, ap plus 3. So this part is sorted. This part is sorted. So what would happen? This pivot would be smaller than this a1. Here, the pivot is smaller than the first index. The pivot is smaller than the first element. So whenever we compare it, we would compare it to the first element, which is a of 0. So again you would compare a of mid to a of 0. And what would find? In this case, we will find that this is smaller. So that means our pivot lies in this range. So you would move the high pointer to this part, 0. And then when we are getting this low equals to high, that is would be our pivot. And then after finding the pivot, we simply apply the binary search algorithm. So let's look at this. So we are first finding the pivot. How? So we are iterating while low is less than or equals to high. We are finding the mid element, and then we are comparing it to the first element. And if it is greater than or equals, that means pivot lies in the right side of mid. So we will do low equals to mid plus 1. Otherwise, we will do high equals to mid minus 1. At the end, when this values exist, low would have the pivot. So simply we would have two array. So low would have the pivot, and then simply would be doing like this: low minus 1 and then low to high. So simply we are calling these two calls low minus 1 and then low to high, like low to n minus 1. And it says that if target is not in the nums, then return minus 1. So here we are checking if both left and right is minus 1, then return minus 1. Otherwise, whichever is not minus 1, return that.